Hi everyone, I'm Chris and welcome back to this machine learning course. This lecture gives an introduction and a basic understanding of artificial neural networks. First, the idea behind artificial neural networks is presented. Then, we will take a look on how to build such neural networks, starting from a single neuron up to more complex, deep neural networks. After that, we examine the individual components of artificial neural networks, such as activation functions. We learn to understand the output of a neural network. To train a neural network, a gradient-based minimization scheme is used. Because a neural network can have a lot of trainable parameters, we need a more efficient approach than finite difference approximations. The gradient calculation is considered at first for a single layer perceptron. This gives the so-called delta rule. Then, the gradient for a deeper neural network is considered. We will derive the famous backpropagation algorithm. Then, we consider how to use the gradients in a minimization scheme. The idea behind artificial neural networks was to imitate the information processing and structures in the human brain. Human intelligence is related to processes in the brain. The brain consists of billions of neurons, highly interconnected. A single neuron is a basic information processing unit. An incoming stimulus is either transmitted or not, depending on the strength of the stimulus. By putting together a lot of these simple units, the complex decision-making process and the intelligent human behavior is done. Of course, nowadays we know that the human brain is much more complex. For example, it has different types of neurons. But the idea still is to build complex information processing structures from simple, basic information processing units. Such networks can be designed to incorporate special features of the human brain as well. For example, our brain is very fault tolerant. That is, it doesn't rely on a specific neuron. Further, we will see how artificial neural networks can be used to recognize and interpret patterns in the data, similar to our brain. Besides the algorithmic implementation of neural networks, the selection and adaptation to hardware to execute the algorithm is important. In the brain, we have massive parallel processing. For a long time, the application of artificial neural networks was limited because of the serialized processing of CPUs in computers. With the rise of GPUs, parallel processing becomes possible. Designed for calculating matrix vector multiplications in 3D computer games, the GPU power can be transferred to neural network algorithms as well. Therefore, we express this algorithm in matrix vector notation. Note that from now on, we will call artificial neural networks just neural networks. Section finished. If you like this video, please click the like button and consider to subscribe this channel. If you have any comments or questions, please leave a comment down below. And thanks again for listening. See you in the next section.